I'm Sofian and welcome into the darkness. So, I'm always fascinated by how our universe works, and movies have played a major role in increasing my appreciation for it. One particular movie that I really enjoyed watching a couple of years ago was Interstellar. In this movie, I was introduced to many interesting aspects about space, but the one that struck my attention the most was black holes. So today, I'll make sure all of you know what black holes are in 5 minutes. I believe learning about black holes should be given the same importance as learning about stars, comets, and meteorite showers, since it allows us to understand what gravity is truly capable of and how it affects the space and time around a massive object. What is a black hole? A black hole is a region in space that contains extreme amounts of mass packed into a small volume, in which gravity is so strong that not even light can escape it. It's black since it doesn't produce light, hence the name black holes. Alright, black holes are not the vacuum cleaners of our space, guys. They are just objects of immense gravity that's going to consume anything if it were too close. So think of it as a whirlpool of our space, in that the heavy currents resemble the gravitational field around a black hole. To know more about this, let's look at the three parts to a black hole. You've got the outer layer, in which gravity is not that strong, so you're lucky enough to escape it. But if you get trapped into the inner layer, this is where gravity is very strong. So you have missed your chances to escape, and you're pulled into the center, known as a singularity. And singularity is just a big word, guys, to describe a point that contains all the mass of a squashed up star. So imagine how strong gravity must be at that point. Now let's take a look at some of the black holes near to us. You've got Cygnus X1, which is just 15 times the mass of our Sun, compared to Sagittarius A star, which is 1,000,000 times more massive and exists in the center of our Milky Way galaxy. Now imagine if I were to compress the whole mass of the Earth right now into a single M&M that I've got right here with me. This would lead to a black hole. So this is the type of object that lives in our universe right now as we speak. To know how black holes are formed, let's look at stars. And I'm talking big stars, not our Sun. So a star in general is a large ball of hot gas that undergoes constant nuclear reactions to produce huge amounts of heat and light energy. You've got two forces that exist within the star: the force of gravity and the force of pressure, two involved in a constant fierce battle to see who can conquer the star. Here, gravity wants the star to collapse, and pressure wants the star to explode. But when the star runs out of nuclear fuel, pressure weakens and loses its will to fight against gravity. So gravity wins the battle, and now slowly the hot layers of the star are going to expand into a giant structure known as a red giant. And now the star won't handle its own mass. It undergoes an explosion known as a supernova. After this explosion takes place, what's left of the star's mass is going to collapse into the star's core under immense gravitational forces, leading to a black hole. These Saturn-like disk rings that you see up there are actually destroyed fragments of stars and galaxies, getting eaten up by a black hole since it came too near and couldn't escape its gravitational pull. So I came near to a black hole, and that's me up there. So the huge gravitational forces are going to stretch my body or spaghettify me until what's left of me are just mere atoms. So believe me, guys, it's not a pleasant experience. Another interesting aspect of black holes is time dilation, one of my favorite. So the gravitational field is going to affect the time system for me. So a minute near a black hole for me would be the usual 60 seconds, but if I look at the Earth's clock system, then that minute would appear less than 60 seconds. This means I'm aging slower. So if I was to spend near a black hole for an hour, that means 6 years would have passed by on Earth. So a kid at my neighborhood would be extremely older than me by the time I reach Earth. How do you detect a black hole? I said earlier that they don't produce light, but we can see how they affect nearby matter that produces light. So the gravitational field is going to cause the destruction of the star. And this destruction of star is going to produce heavy X-ray and light emissions that can be detected by satellites and telescopes here on Earth to find a black hole. So that's it. We found our black hole. Now what? Black holes are a really strange yet an important presence in our cosmos right now. They shouldn't be ignored just because it's difficult to find one, since they hold a lot of answers to our universe. So in order to obtain light, you must seek darkness, and that is black holes.